Here is a graph that represents function a, which is defined by the formula a of s equals s squared, where s is the side length of a square in centimeters. Name 3 possible input-output pairs of this function. We can describe all possible input values for function a as all numbers greater than or equal to 0. How would you describe the set of all possible output values for function a? The possible outputs of a are also all numbers greater than or equal to 0. Now let's look at another situation. Function r is defined by r of n equals 40n, where n is the number of campers at a camp. Is 20 a possible output value in this situation? What about 100? Explain your reasoning. No, neither 20 nor 100 can be outputs because the input, the number of campers, cannot be a fraction. Here are 2 graphs that relate the number of campers and camp revenue in dollars. Which graph could represent function r? Explain why the other one could not represent the function. The second graph could represent function r. The first graph could not represent function r because it includes fractional n values, which don't apply in this situation. For the second graph, describe the set of all possible output values of r. The outputs of r are all multiples of 40 between 200 and 640, 200, 240, 280, and so on.